In South Dakota, soybeans are big business, and as the state's largest agriculture export crop, they are a cornerstone of the state's ag-based economy. South Dakota State University researchers are looking to improve the crop's value and help farmers save on input costs by reducing the plant's need for nitrogen fertilizer.
The goal of our project in the long term is to develop a variety where we have nodules that are still functional and fixing nitrogen and supplying the nitrogen that is required by the plant during the seed filling stage and the seed maturation stages where the demand is high. So we want to increase the productivity of the soybean as well as reduce the environmental effect by reducing the nitrogen that we are putting in. It will also reduce the cost for the farmer so that it will add in to the profits.
When the plant reaches later growth stages, they are unable to supply the necessary amounts of nitrogen. Synthetic fertilizers are often applied to ensure the crop meets its nitrogen needs. But Petla believes that by delaying the maturity of nodules, the natural process of nitrogen fixation could continue to meet the plant's nutrient needs later in the growth cycle, greatly reducing the need for fertilizer.
So we are trying to understand how we can improve the soybean nitrogen use efficiency by delaying the maturity of nodules. These nodules are like the nitrogen fixing factories for the plant, so that we don't have to supply nitrogen to the plant in the form of nitrogen fertilizer.
The researchers believe different genetic variations in soybeans can result in a higher number of nodules with delayed maturity.
With the previous research, we have identified certain cytokinin and auxin hormone genes, pathway genes, that are involved in plant development in general and also in the nodule development specifically. So what we're trying to do, we have a list of cytokinin and auxin pathway genes, and we are trying to target these specific genes and see if it affects the nodule maturation and development stages.
To find the specific traits, the researchers will need to test over 1,000 different genomes. Once they have identified the traits, they will work with plant breeders to incorporate these traits into elite high-yield soybean varieties.